So I don't really like the way that the book does the next section. So we're going to kind of go off and do it with this investigation. If you can't print it out, it's totally fine. Just make sure that you're taking notes as we go. But this will be in place of the properties of, I believe it's section, oh darn, I think it's 8.5. 8.5 properties of logarithms. Okay, so keep in mind logarithms and exponentials are the inverses of each other. So the properties of exponents are going to apply to the properties of logs. Okay, so let's take a look at this first example. It says log base 2 of 8 plus log base 2 of 4. We're going to evaluate that expression. So log base 2 of 8, 2 to the what power is 8? Well, that's 2 to the second power, so we can replace this with a 2. And 2 to the, I'm sorry, 2 to the third power, golly, 2 to the third power. And then 2 to the what power equals 4, that's to the second power. So this can be replaced with a 3, this can be replaced with a 2, so 3 plus 2 is 5. Okay, so we can say that we're going to say equals 5, go over here. So we're going to go the other direction. 2 to the 5th power equals 32. Interesting. So look at this. What is the relationship between log base 2 of 8 plus log base 2 of 4 equals 5 and log base 2 of 32 equals 5? Interesting. I'm going to let that hang there for a minute and you can think about that. Let's go to the next one. 3 to the what power equals 9? So 3 to the second. And then 3 to the what power equals 81? That'll be 4th. So 2 plus 4 is 6. So 3 to the 6th power is 729. Interesting. I wonder what 9 and 81 and 729, what that length is. I guess we'll have to think about that. Okay, 3 to the what power equals 1/9. So this will have to be a negative power, right? Because we're going into a fraction. So that'll be a -2. And then 3 to the what power equals 81. We just did that one up there. So -2 plus 4 is 2. So we come over here. 3 to the second power is 9. Huh. And then let's think about what would the relationship with 1/9 and 81. All right. Let's go to the next one. 5 to the what power equals 5. This could be replaced with a 1. And then 5 to the what power equals 1. That can be replaced by a 0. 1 plus 0 is 1. So 5 to the first power is 5. Interesting. So there's a pattern here if you haven't picked up on it yet. So the bases are the same. Log base b of u plus log base b of v equals log base b of, did you notice, 8 and 4? 8 times 4, 9 times 81, 1/9 times an 81, 5 times 1, so this would be equal to u times v. So let's use this rule to solve these before impossible problems, right? Because 6 to the what power equals 12? We have no idea. That's going to get into something weird, but we can use this property now. So this could be written as log base 6 of 12 times 3. So that's log base 6 of 36. 6 to the what power equals 36? 2. Okay, I do the same thing. Now, FYI, if there's no base written, it is 10. So this will be log base 10 of 250 times 40. Well, 250 times 40 is 10,000. So log base 10 of 10,000. 1,000. So that will give us 4. Ooh, this one looks fancy, right? There's fractions. Let's give it a try. Log base 8 of 3/64 times 1/3. Oh, this becomes 1/64. So log base 8 of 1/64. Well, I know it's going to be a squared, right? Because 64 and 8, that's the relationship. But it's a fraction, so it'll have to be a -2. So why does this work? Let's look at a proof. Suppose these are both true. B to the x equals u and b to the y equals v. We're going to rewrite both as log equations. So log base b of u equals x, and log base b of v equals y. All right, put that to the side. Now we're going to multiply the left and the right sides and make it one equation. So they did the right side for you, u times v. Let's do the left together. B to the x times b to the y. And then using your rule of exponents, b to the x plus y equals uv. And now we'll write this as a log equation. So log base b of uv equals x plus y. And then replace, we'll do a little substitution. X is equal to this, y is equal to that. So log base b of uv equals x is log base b of u plus y is log base b of v. So this is a little algebraic proof why that works, okay? All right, next we're going to do subtraction. So let's do it the old way. 5 to the what power equals 625, so this would be to the 4th, minus 5 to the what power equals 5 is 1, so 4 minus 1 is 3. So log to the 3rd power is 125. All right, same thing over here. 6 to the what power is 36, this can be a 2, minus 6 to the what power is 6 is 1, so this is 1. So 6 to the 1st power is 6. Alrighty, next log 3. So 3 to the what power is 9 is 2. 3 to the what power is 1, so 0. So that's 2. So 3 squared is 9. 2 to the what power is 16, that's a 4, minus 2 to the what power is 32, that's a 5, so that's a -1. So what will make that a -1? 2 to the -1st power is 1/2. So let's look at our relationships, 625 and 5 and 125. Maybe this one's easier to see. 36, 6, and 6. 9, 1, 9. 16, 32, 1/2. So it looks like when you subtract, you are going to divide. First divided by second. So let's try these, guys. They were previously not possible. Now we can do them. So this is log base 6 of 72 over 2, or log base 6 of 36. So this equals 2. Log, this will be a base 10, right? There's no base written, of 12 divided by 0.12, which is log base 10 of 100. So this will equal 2. Log base 12 of 2 divided by 288 is log base 12 of 1 over 144. So this will be a -2. All right, so let's do our proof really quick. Log base b of, I've got a little gnat. Log base b of u equals x, and log base b of v equals y. Divide the left sides and the right sides. So they did the left side for us, so we'll do b to the x over b to the y. And then rule of exponents, this will become b to the x minus y. equals u over v. Writing it in log form, this will be log base b of u over v equals x minus y. Substituting our x and our y, so log base b of u over v equals x is log base b of u minus y is log base b of v. So there we go. Algebraic proof, it works. Next, turn the page. We're getting close to being done, guys. Here we go. So log, these are interesting. Log base 2 of 4 to the third. So that can be written as log base 2 of 64. So 2 to the what equals 64? That's going to be 2 to the 6. We'll go to this side in just a second. Let's do this guy. This will be 3 to the, well, square root of 9 is 3. So 3 to the third is, pardon me, 3 to the first is 3. This will be, and you know what, I'll rewrite it too, just for, there we go. This can be written as log base 5 of 25, so 5 squared. And this can be written as a number I don't want to write, so I'm not going to write it right now. Okay. Let's think about how we can relate these. Interesting. So 2 to the something equals 4. 2 squared, right, is equal to 4. So this can be written as 2 squared equals 4. But I don't want 2 squared to equal 4. I want 6, right?